All right, so in our last video, I did Natas 10. I got up to Natas 10. So today we're going to start with Natas 11 and see where we can go. Noticeably toward, when we got to 10, things were a little bit more difficult. I anticipate they're going to probably get a lot more difficult, so each video may just cover one level. We'll see what happens. So where are we? We open our start a TMUX session, split my screen, and open my password file, which I call natas.info. I keep all my passwords from each level in here, and then we'll use this other side to, do scripting work if we need to. Yeah, so we did a little bit of scripting in level 8 and 10. So let's see what happens. Let's check out level 11. Let's jump in. I get that right? Yep, okay. Natas 11 and the password. Okay, so cookies are protected with XOR encryption. Interesting. Let's see what that means. So let's just go ahead and go straight to the source code since we have access to it. See if we can figure something out in here. Excuse me. So we've got, let's just start from the bottom. So these are functions, they don't actually execute until they're called. So we have an array of default data. The show password element in that array is set to no, and the background color in that array is set to 6F. So this is hexadecimal for white. You probably all know that, but just in case. Then we've got an XOR encrypt function. We have a load data function and a save data function. First thing that happens on the page is we call load data with our default data. So what happens in load data? So load data makes the cookie variable or the cookie array be global, which means it's accessible from anywhere in the code. It sets my data to def, which is what we're calling the data passed in. So this def at this point is default data because that's what's passed in. So my data is the default data. Then we're looking to see if there's a data element in our cookie array. So does our cookie contain a data element? If it does, so this is true if true, it looks like we're going to decode that data. So first we're going to base 64 decode it, then we're going to XOR encrypt it, and then we're going to JSON decode that. So base 64 decoding is a PHP function, XOR encrypt is here, and I believe JSON decode is a PHP function, but let's just make sure. Yep, so I'm assuming it just standard takes JSON data and decodes it. All right, so let's see what we've got. All right, so then we're looking to see is the temp data is what was decoded an array. If it is an array, does the show password key exist in that array? If it does the background color exist in that array? So I think this is just basically validating that the information in the cookie element data is correct. And then it comes, then the next we're looking, so if preg match, so if the background color, so this is, when you're doing regular expressions, the caret means the start of your string. So does our background color start with a pound sign? And then does it contain, so this parentheses basically means, does it contain any of these characters through the end? And it's expecting it to be 6 characters long. So it's looking for the alphabet or a digit, essentially. So 6 characters that are either A through F or a digit. Sorry, not the full alphabet. A through F and a digit, and 6 characters long. So is the background color actually a background color? If it is, then set my data to my data show password element to whatever was in the cookie, right? So the temp data holds what was in the cookie, and set the background color to what was in the cookie again. And then at the end, return my data. So this is out here. So my data is either what was passed in or what was constructed from the cookie. So we return my data. So now data equals whatever came out of this function. Then we're checking here if array key exists in the request. So if background color was passed in via either get or post method, so request holds either get or post data. And this is again the same regular expression we saw here. So this is just checking to make sure our background color is in fact a background color. Set our data background color to what was in the request. So if it's different from what was in the cookie, we're changing it here. And then save data. So what does save data do? Save data sets the cookie to whatever was in D. So in this case, data. So here data starts off being, well, nothing. But data could either be the default data, depending on what came out of here, or it could be what was in the cookie that was passed in, or it could be what was in the cookie that was passed in, edited by what was in the request. So hopefully that makes sense. So I think what we're going to see here, based on this code, I think what we're going to end up doing is we're going to end up grabbing the cookie out of burp, and we're going to try to first decode it. We may actually not need to do that. We may be able to just take this default data, change it, pass it through the XOR encrypt. Well, first we would JSON encode it, pass it through XOR encrypt, and then base64 encode it. So if I change this, let's see, take that out. This is level 11. Default data. Then let's grab the XOR encrypt function. After this. So I'm using Vim, the Vim editor, and I have auto indent turned on. So if I just paste, I'll just show you what I keep doing. So if I just paste, it auto indents everything. So I have to set my no AI, no auto indent, and then I can just paste it in, have proper or reasonably good formatting. All right, so let's, oh, we don't know what the key is. We have to figure out what the key is. So here's what we don't know. So we go through this code, we don't know what the key is. So we have to figure out the key. So XOR is, how do I explain this? The result of an XOR, an exclusive OR statement, is such that if one or the other values is true, then the result of the XOR is true. If both are true or both are false, the XOR is false. So here on line 11, we see, I'll highlight it. Let me move my cursor. This caret here in this context means XOR. So if text $I, if the character at position I in the text array is true and the text in the key array at this element is false, then out text will be true, and vice versa. Let me just do a little. Let's see how XOR works with strings. XOR cipher. Okay, so it's XORing the bits in the character. So it's XORing the bits in the character, and then giving me the out text. So if let's see, what's a well, let's say character A is represented by 0010, 1111, and character B is represented by 0011, 0000. Then the resulting XORing that, the result would be 00011111, and that's because so in the case where you see a 1 and a 0, the result is 1. Where you see a 1 and a 1, the result is 0, and the 0 and 0, the result is 0. So this XOR function is looking at each character and the bytes that make up those characters and coming up with the XORed character, right? So whatever this represents is the output. Hopefully that makes sense. And so we need to figure out what the key is, right? So we can reverse this. I have to think about how to do that. First, we got to figure out what our input data is. Close this, and go here. Don't know. I should have a cookie though, so let me see if I've got a cookie. Can you guys see this? This is the cookie value. So we've got this is actually the output of this function. So we need this. Let me grab it. Whoops. Got this cookie value. So I see a percent sign here, and I know that percent 3D is an equal sign. So I'm just going to go ahead and replace this with an equal sign, which is 1. So that's a base 64 encoded string. So let's see. So what we're going to do with this is we want to reverse it. So we want to see what this was prior to setting the cookie to this. So how we do that is we will JSON decode XOR encrypt base 64 decode C. Sorry, let me see. All right, so we've got, first let's base 64 decode. I'm going to comment this guy out. So base 64 decoded is and then so the data, so that will be Setting the cookie. We know what the data was when we passed it to JSON encode. Right, so in this case, it's the default data. So we know that this was what was passed to JSON encode. So we know that this is actually one input. So we know that the default data is the input to the XOR encrypt, right? So whatever we encoded that data to be is what was passed into our XOR encrypt. So input, input XOR equals JSON encode D. So I'm going to change, because I don't want to type out these variable names and I'm using an editor that's really kind of a pain in the ass. I'm going to just call this variable D. So that's our default data. So this is the input to our XOR, and this is actually the output from our XOR. So does that make sense to everyone? So here is, you can see here on line 19, we are passing in the data to JSON encode. That encoded data is what's going into our XOR encrypt, right? And then something's coming out of XOR encrypt, and then it's getting passed to base 64 encode, and that's what's used as the cookie. So if we can just base 64 decode the cookie, we know the output from our XOR encrypt function. So we know the input and we know the output. What we don't know is the key, but the key is easy to get because all we have to do is XOR our input and output, and we should see the key in there somewhere. So let's, wonder which one is longer. Let's print these guys out. It's probably not going to be pretty, but let's just see what this gives us. I'm probably also going to end up with some errors that I have to sort out. Yep, of course, line 25. What is my error? Oh, this guy doesn't have a semicolon at the end. Hopefully that's it. Yep, okay. Weird. They apparently already have new lines at the end. So let's, okay, right. So input is this guy. That didn't have an output is this guy. So we've got both. And I believe probably in this case that our output is longer. So let's make the output, let's look at the function. So we're assuming the key is shorter than the input. So let's make the key, let's just pass them both in. Now text. Um, Actually, let's reverse this. Won't matter. It'll have the same result, I think. Let me give it a new line. Whoop, syntax error. What? Forgot to close my quote. So I think this is probably going to be, so this is repeated over and over again. I think the key is going to be QW8J. That's what I think the key is. I don't think it's all of this. So let's see. So now what do we need to do? Now we need to change our default array. So now let's change D. Actually, and say show password is yes. And now let's call XOR encrypt with D, and our key, whoops, crud. So this hopefully is going to give us the beginning of our cookie. I'll probably have to call JSON. So I have to JSON encode the data. Right, and then what did I say our key was? I said it was QW8 capital J. Copy that. And then we want to base 64 encode. So I think this is going to give us the cookie value we need to send, I think. Let's see what we get. Let's try it. I believe this is what we need. So I'm going to turn on intercept in burp, and I'm going to go back and click set color. And I'm going to come in to burp here, change this value like so, and forward it. If that worked, this will be a miracle. That worked. Holy wow. All right, so let's see. Let me see if I need to revisit anything I just did. So just to walk through it again one more time. So first I needed to find out what my original input. I needed to figure out the key in the XOR encrypt, right? So in order to do that, I needed to figure out what my input was and what the output was when it was called in the set cookie function. Once I had that established, I could then use those two pieces of data to determine the key, because XOR is not encryption. It is easy to reverse if you have the inputs and outputs. So I got the key, and once I had the key, all I had to do was change my default data to say show password equals yes, provide that key, use the exact same code used in the set cookie function, get my new cookie value, intercept the request, and populate the new cookie. And then here I have the password now for Natas 12. So very cool. All right. So that's it for Natas 11. Next video will be for Natas 12. Thank you for tuning in.